I have a
All
small,
right.
yeah, I have a place. I'm in the hotel right now, so no issues.
All right.
Yeah.
So what is happening in
So,
school?
so we have completed matrices, determinants, inverse,
All right.
then inverse functions. Then we have completed differentiability and continuity.
Mm-hmm.
Yeah.
So see, determinant and matrices are comparatively easy. So we'll start that later. All right.
Yeah.
So did you understand everything in inverse Trigo?
No, inverse trigger was the worst part. Like I knew
First
a
part,
bit
right?
of it, but yeah.
All right. So let's
Yes.
start with inverse Trigo. Is it okay?
I'm fine, but no one else is going to join today.
I don't know about this cell. I think
Oh,
one student was coming, one more student, but
okay.
I don't know yet. All
Okay,
right.
no problems. All right.
All right. So inverse Trigo. What is inverse Trigo? First of all, we have to understand this. Before understanding even this, we have to understand a little bit about functions, right? What is a function?
Right. Inverse function is something like A, B, C. It's like a part of relation.
Absolute right. It is a relation. Every
Oh, it
function
is
is
a
a
relation.
relation,
Okay.
right? So if I join A to 1, B to 2, C to 3, and D to 4, then I can say this function, this is a function. Why? A has an element in B, B has an element in B. Suppose this is set A, this is B. Right? Every element of set A is related to at least one element in set B, right?
Right, sir.
And every element is related to only one element.
Right.
What this means? A is related to only one. If I draw another line, A is related to 2, then this will not be a function. All right. Every element of A
Yeah.
must be related to only one element of B. All right.
Right.
So this is called a function. Why am I telling you this? To learn about inverse function, we have to know about function, right? So
Yeah.
to remember this, I give one example to every student. So please remember this. Suppose this is set of all sons. This is set of all fathers. All right. All the sons in this
Right.
world, all the fathers in the world. What I'm saying, all sons in this world always have a father, right?
Right.
If there is a son, that means there is a father also.
Right.
So all the elements of this set must have a father, right? And every child has only one father, right?
Right. Right.
So that is the condition of function. Every son must have a father, and every son must have only one father. But and something else we can say 1, 2, 3, 4. Suppose
But
A and
one
B.
father can have many sons.
Absolutely right. See, you understand very clearly, right?
Yeah. Yeah.
So that is okay. If A is joined to 1, A is joined to 2, then 1 is the son of A, 2 is the son of A. That is okay, right? So this is a function.
Right.
This is clear now.
Right.
So always
Clear.
remember this example. All right.
All right.
So
Got it.
in inverse function, if one function is invertible, that means we can find out the inverse. Then there is a condition. I'll go into detail when we are doing the chapter relation and function. Now I'm just going over this, right? So to make something invertible, a function has to be 1, 1, and onto. 1, 1. What is 1, 1, and onto? One father, one son, one father, one son, one father, one son, and all the fathers also have only one son. All right.
Right. Right.
So this is
Onto
called
and
1, 1,
one is same, right?
no, not same. 1, 1 means one father, one son, one father, one son, one father, one son. Onto means all fathers also have a son, right?
All
Suppose
fathers
I
have
write,
one. Okay.
it element D here. Then this is also a function, right? There can be a father who doesn't have a son. That is also okay, right?
Right.
But for this function to be onto, all fathers should also have a son.
Okay. Okay. It's
All
like
right.
condition should be effort from both the sides then.
Absolutely.
Mm.
All right.
Right.
So this is 1, 1, and onto. Now, why is this necessary? If function is not 1, 1, and onto, then we cannot invert that. That means we cannot find the inverse of that function. All right.
Got it. And the opposite of
So
onto is into function, right?
right. not, we don't say opposite, but yes, we can say it's like that. All right.
All right.
We'll go into deep detail when we are doing the chapter relations. All right, don't worry about that. Now let's start inverse trigonometry function.
Okay.
So if you remember the Sine X graph, it looks like something like this, right?
Yeah.
So if I ask you, is this 1, 1, then what would you say?
No, I didn't get you.
If I ask you, is this 1, 1 or not? 1, 1 function or not?
It is a 1, 1 function.
No, this is not 1, 1. Why? Let's see.
Oh,
1,
okay,
1
it's
means
not.
one father have one son.
So okay, so if it was 1, 1, only one cycle would be there.
Right.
Okay.
And also not even one cycle. See, if you draw the whole cycle, then this is also not 1, 1, because see, if I draw, we are getting, suppose this is half and this is half, and for the same y we are getting 2x, right?
Yeah, got it. Right.
So this is
right.
also not 1, 1. So what we do, what mathematicians in this previous generation did, they restricted the domain. What they did, like you said, one cycle, they even made a smaller cycle. That means they only draw like this, minus pi by 2 to pi by 2. They said cannot see anything beyond this. There is no graph beyond this, right? Now if you see, for each y there is only one x, right?
Right.
So this becomes 1, 1. All right, now we can inverse this. All right.
So you can also say that it is +1 and -1, the domain.
Absolutely right. We'll go into the domain, right? But yes, the domain is -1 to 1. Why? See,
Minus
the maximum value here is 1,
1,
minimum value is -1,
-1.
right?
Right.
Let me draw this graph very clearly. This is sin x. We'll make a comparison. All right. This is minus pi by 2. This is pi by 2. This is 1. And this is 1. All right. And see, we didn't have to restrict this graph this. We could have restricted till this, right? That is also okay. That is also 1, 1, right?
Right.
If I take a graph from here to here, that is also 1, 1, right?
Right.
So all of these graphs are possible, but this graph here from minus pi by 2 to pi by 2 is called principal value branch. All right, because we need something standard, right? If you are talking about sine inverse, I am talking about sine inverse, then there should be something fixed, right?
Right.
Because how would we know which graph we are talking about, which domain we are talking about? So they fixed something which is minus pi by 2 to pi by 2, and they call this principal value branch. All right.
All right, got it.
But one thing to understand is there many graphs are possible, many domains are possible in inverse function, in trigonometric inverse function. All right.
All right.
Here domain of sin x is,
domain of sin x will be again +1 to -1 to +1.
no, sin x. We are talking about sin x. What values can you put in sin x?
Sin x would sin x here is the graph, right?
Yes, domain means, yeah, sin x graph is this whole graph.
Yeah.
The
Here,
domain of
so
sin x is
domain of sin x will be
r. You can put any value, right?
No, I'm not getting it.
Let me
Sin.
explain. See, sin x graph is this. This graph goes till infinite, right?
Right.
So domain means x. At what x the graph exists. So we can see the graph is extending to minus infinite to infinite. That means domain is
minus infinite to plus infinite.
Right. So that we can say r. R means real values. All right.
Right.
And range is range of sine x. See, domain always check in x-axis, range always
Right.
check in y-axis.
Okay. Okay.
So what is the maximum value sine x attains this maximum value here? This is 1.
Maximum is -1. Okay. In sine x, okay.
1.
Sine x 1. Okay. 1. Okay. 1.
And minimum value is -1.
Got it. Got it.
So -1 to 1 is the range, and this is called closed brackets, right?
Okay.
You know
Close
about this,
brackets.
right?
Yeah.
Closed
Close
brackets
brackets means
included.
only in between those. Yeah. Included. Only between
Included.
the brackets that would be there.
Right. All right. So this is called sine x. Now for sine inverse x,
So domain is all the real values in the curve.
all the real values in this world, whatever real value you can think, you can put in sine
Okay.
x, right?
Got it. Okay. Got it.
But not
So
in the case of sine inverse, right? See how to draw
Right.
the graph of sine inverse. Always draw this point. See, this is 0, 0. So graph will pass from 0, 0. This is pi by 2, 1, right?
Mm.
And this is minus pi by 2, -1. So when drawing the graph of sine inverse x, reverse this. So 0, 0 will be there. One graph will be 1, pi by 2.
1, pi by 2.
Always
Okay.
inverse this, right? Because inverse function pi by 2, 1. So 1, pi by 2. So 1, pi by 2. This is 1, and suppose this is pi by 2. Then 1, pi by 2 will be here. And we have
Okay.
another point minus pi by 2, -1. That means -1, minus pi by 2. All right.
All right.
Now we can just join this graph, and this is the graph of sine inverse x. All right.
So this will move
Easy?
in. Yeah. So this will move in a vertical way then.
Vertical way, right? Because this inverse functions are always symmetrical about origin. How to explain
Got
this?
it. Like
If you keep
the
a mirror,
origins will be.
then
Yeah, it's like a
if
mirror
you keep a
image.
mirror, right? All right.
Got it.
Give me a second. I think my laptop is not charging. Give me a moment.
No issue, sir.
All right. So this is the graph of sine inverse x. All right. And look at the domain and range here. In sine x, we put Sahil, you are there, right?
Yes, I am there.
All right. So in sine x, we put graphs and we get values. But in sine inverse x, we put values -1 to 1 and we get angles, right? Because inverse will
Right.
happen. So here domain we can write. Look at x-axis. What is the value of x-axis? The graph is drawn.
Here the value of x-axis is 1.
-1 to 1, right? See, minimum
Okay.
value
Okay.
x-axis.
Okay. Minimum
-1
value.
to 1.
First one is
Right.
1. Minimum.
Minimum value is -1. Maximum we are moving to 1.
So we
right?
can't write 1 and -1.
No. This is the way we write. Always minimum value, then maximum value. All right.
All right. Got it.
And range. Look at y-axis. What is the maximum value graph attains and minimum value graph attains?
Minimum value is -pi by 2. Maximum is pi by 2.
Absolutely right. So this is the range of sine inverse x. This is clear.
Clear, sir.
And this is called principal value range, principal value branch.
Of sine inverse x.
Right. All right. Please draw these graphs, write down the domain, and please try to draw the graph by yourself without looking at this. If you cannot, then look at this. All right.
All right. Sure.
And still have any, if you still have any doubts, then you can ask me. All right.
All right. I'll start from this both graphs, right? Nothing to draw from the top.
Yes, yes.
Top
Please draw both of
yeah.
the graphs so that when you
Okay.
revise, you'll get the idea.
Okay. In Sine X, pi by 2 is the x value and 1 is the y value, right?
Right. Absolutely. Because see, sin x, what does sin x demands? Sin x demands angles to eat, right? This function
Right.
eats something, and it eats angles, right?
Eats something means?
Eats means we take the input. Input is angle, output is value,
Okay.
right?
So
In class
sine
10th,
inverse
you
x is
in class
then
10th you
okay.
wrote sine 30, sine 60, sine 90, right?
Yeah.
So that are angles,
Yeah.
and you got some value. Sine 30 is 1 by 2, 1 by root 2, and so on. So those are angles. So sin x
Right.
eats angles, but sine inverse x eats values because that is the inverse. All right.
Means it will be sine 1 by 2 will get 30 degrees.
Absolutely. Sine inverse 1 by 2, we will get 30 degrees.
Oh, sine inverse. Okay. Okay.
You
Sine inverse 1
get my
by 2.
point?
Okay, got it.
But now it's, I think you are clear about this, right?
Yeah, pretty clear.
Yeah. All right.
Tensor.
All right.
This principal value branch is including the domain and range or just range?
Range. Because see, domain is always -1 to 1, right? Because sin x cannot go out of beyond 1, right?
Right.
So domain is always same, but range is changing. All right.
Exactly.
So in competitive exams, they may ask you questions, they will change, right? This range they will change. So you have to change the
They can
questions
put.
accordingly.
Yeah.
All right. because we saw the graphs we can change. We just have to make it 1 1, and that we can do in many ways. But this in boards, this is the thing they always ask. All right.
Got it, sir.
Yeah. Now let's draw about cos x. This is absolutely crystal clear, right?
Yeah, clear, very clear.
All right. Cos x. So cos x graph, we can draw till this and this. Let me draw in dot 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 dot. This is the graph of cos x, right?
Yeah, just the same like sin x, but the value changes.
Correct. So here what we do, we restrict the graph from 0 to pi, because see again, this is 1 1. For 1 y, we are getting only 1x, right?
Right.
So we are restricting the graph from 0 to pi. This is clear?
Will be 1 to pi.
0 to pi. 0 to pi.
0 to pi, right? 0 to pi.
So first we can write domain of cos x is again r minus infinite to infinite, and range
Right.
is
the y values, which is
this is the maximum,
yeah,
this is the
yeah,
minimum.
maximum. Right. So it will be 1 and minus pi, right?
Minus 1 to 1, right?
Minus 1 to 1, okay.
So cos inverse x, again let's draw the graph. This point is 0 comma 1. This point is pi by 2 comma 0. This point is, sorry, this is pi comma minus 1. So we have to just interchange the values. So first we can get 1 comma 0. So 1 comma 0 will be here. This is 1 comma 0, right?
Right.
Then we have to get pi by 2 comma 0. That means 0 comma pi by 2. So 0 comma pi by 2. Here we'll have, this is pi by 2. So this point is there in the graph. Now we have pi comma minus 1. That means minus 1 comma pi. So here we have the value of pi. So this is minus 1 comma pi. So we have 3 points. So can you draw this graph like this?
So it will come same like that vertically again, right?
Right. This is clear?
Yeah. Clear.
Again, we can see the cos x eats angles, but here cos inverse x eats values and
So only
like this.
Okay, so range of sin x and cos x is same.
Absolutely right.
And then here range of cos, domain of cos inverse x will be it will be the x values, which is minus 1 to 1.
Absolutely right. See, and
range will be pi to, it will be pi, right? Pi
right,
to
right,
minus
absolutely.
Pi to minus. I mean,
minimum value.
Minus
minimum
pi to
value
pi.
of graph. Minimum value of graph is this, and this line is
zero, zero
x
is
axis.
0.
0.
Yeah,
So 0 to pi.
0 to pi. Right. 0 to pi.
All right. So again, this is principal value.
Yeah.
So please draw it out. Don't look at the screen, right?
Yeah.
First try to draw by you or by your own. Then look at the screen. All right.
Right. So there's no way that the cos X graph will cross the origin, right?
No. For cos inverse, that will not cross the origin because we have
Even
restricted the graph from 0 to
even
pi.
even cos X graph won't cross the origin.
No. Cos X graph does cross the origin, right? Because you are asking cos inverse or cos X.
Cos X and cos inverse both won't cross the origin.
No. Cos inverse won't, but cos X does, right? See,
How?
remember the cos graph like this.
Yeah. So
So this crosses the origin, right?
no, like goes through the origin. I mean, like sin X
Right.
passes.
No. That doesn't pass through origin, right? Because at 0,
Yeah.
0, cos 0 is not 0, right? Cos 0 is 1.
Right. Right.
Cos
That is
0
my
is 1.
question. Yeah.
All right.
Yeah.
No, actually, you said crosses. That means I thought.
Yeah. Okay. Yeah. My bad.
All right.
Actually goes through it. Yeah.
No issues. It's
Yeah.
see, we are here to solve your doubts, right? Not mine. So you can ask
Yeah.
anything. All right.
Yeah.
So just give me 1 minute. All right. I'll be back in 1 minute.
No issue, sir. I'll complete the graph till then.
Done, sir.
Done, sir. Done.
All right. Let's move on to next graph. See the most difficult thing in this chapter is graphs, right?
Right.
After that, everything is easy.
Like, yeah, I
Right.
understood that thing, that if I understand a graph clearly, I can solve any numerical.
Absolutely right. So tan x,
Yeah.
how will tan x minus pi by 2 pi 3 pi by 2. So tan x has a graph that go infinite to infinite, and it looks like this. All right, a very bad graph I have drawn, but
No
you
issues.
understand, right? So
Yeah, I understand.
in here we can draw dot thing. All right. So tan x, domain of tan x, we can see in x-axis we can put anything, but we cannot put pi by 2, minus pi by 2, 3 pi by 2, and so on, right? Because they are getting infinite or minus infinite, right?
Right.
Because sin x upon cos x is 10. So if cos x becomes 0, then this will give us infinite.
Yeah,
so that will be an issue.
indifferentiable. Yeah.
Right. So
Indefinite.
domain will be all real numbers except odd multiples of pi by 2, right? We cannot put pi by 2, 3 pi by 2, 5 pi by 2, minus pi by 2, right?
Right.
Odd multiples of pi by 2 we have to remove. So odd means 2n plus 1 pi by 2. This is clear?
Odd and what does n stand here?
N is any integer,
Any integer.
right? So 2n is always even, plus 1 is always odd.
Right.
Odd we always represent as 2n plus 1. Odd multiples of pi by 2. So we can write 2n plus 1 pi by 2.
And what is that like after including? N is included in?
This n belongs to z.
Oh, z. Okay. Then
Okay.
okay. Yeah.
And range is, we can see this goes from minus infinite to infinite. So, or we can say R. All right.
All right. Got it.
Now tan inverse. See, in tan x, we restrict the graph from minus pi by 2 to pi by 2. All right. So the maximum value it will get is pi by 2. Minimum is minus pi by 2. So let's draw the points. So 0, 0 will be there. And this is pi by 2, infinite, right? This is pi by 2, infinite. So we have to draw infinite, pi by 2. Right, Sahil?
Right, sir. Right.
So infinite x, that means you have to move till infinite in x till the end. Then you will reach pi by 2. So we can draw a point here which will not touch the graph pi by 2, right? That will seem like it will touching the graph. And same with this, because in here this is minus pi by 2, minus infinite. So we have to draw minus infinite and minus pi by 2. So when you go to minus infinite in x, it seems like it is touching minus pi by 2. So somewhere like this. So graph will be.
So the range of this tan x and sin x is same. It's like even sin x is minus pi by 2 to pi by 2, right?
Absolutely right. So here, but there is a slight difference. I'll explain, but just tell me the domain here of tan inverse x.
So domain will be 1 second. Can I write the values of in the graph?
Right. See,
Okay, so values this will be minus this will be 1 or minus 1. This is minus 1, right?
X we are moving to minus infinite.
Okay, infinite.
See, in this
okay,
graph,
there won't be 1. There won't be 1 minus. Okay, so it will be minus infinite.
Minus infinite to infinite.
Infinite to infinite.
Or
And
we
then
can say all real numbers.
All real numbers.
Right. The range will be
minus pi by 2 to pi by 2.
Right. But here we have to use open brackets because we cannot reach to minus pi by 2 or pi by 2, right? We'll never get pi by 2 or minus pi by 2. But in sine inverse x, we were getting minus pi by 2 and pi by 2. So this is the difference.
Open bracket means any value inside pi by 2 and minus. So we can't take those values.
Absolutely. So open brackets means this parenthesis. Parenthesis means we cannot include these values minus pi by 2 and pi by 2. But close bracket
the values
means,
but the values between them we can take.
Yes, everyone between them is included. Right. See, look at the graph. This is pi by 2. The graph is not touching the line pi by 2, right? There is small gap.
Right.
In here also there is a little gap, but all the numbers between them, there is a part of graph in that, right? If I draw a
Right.
line like this, it will touch the graph, it will touch the graph, everyone will touch the graph, right?
Right. So can we write
This is
-1 to 1 because pi is 180?
no.
You
Pi,
can't do that, right?
no. Always draw in radians. All right, write in
Okay,
radians.
got it. Got it.
In 11, 12, we don't write in degrees.
Right. Radians, always radians.
Yeah, please note it down.
Yeah. The graph of tan x is not continuous, right? Tan x and minus tan
No,
inverse x.
they are continuous, right? You can see the graph. See, continuous, how to check? If you don't, this is very easy trick. If you don't drop the pen when joining, like drawing the graph, then the graph is continuous.
Okay.
All right.
So there, if there's breaks between the graph, then it is discontinuous.
Right. So suppose I have to draw a graph like this and then this, then I have to, right, take the pen
Right.
out for once, right? So that is not continuous. All right.
Okay.
Yeah.
Okay.
We'll do that in detail also. Don't worry.
Okay.
All right.
But in this tan x, that means there are for each of the graph, like each of the line. Uh. Okay. No, nothing. Got it. Clear.
Right.
Clear.
10x is not continuous. 10x is not
Got it.
continuous.
Yeah. Then so.
All right. So let's draw Cortex graph. This is absolutely clear, right?
Yeah.
All right. This notepad sometimes hangs. All right. Let's see Cortex graph. This is 0. Pi minus pi minus 2 pi. Just pi by 2 minus. So Cortex graph looks like this. There is some more curvature on this. Alright.
Right. So this
If you want, I
passes
can
through
show you on online. Yeah, passes through pi by 2 and
Yeah.
becomes infinite at pi and 0. Alright.
Yeah.
So here also Cortex domain, you can say, see
Domain
all the
will
values,
be
yeah,
all the values
but
except odd values of pi.
odd values of pi. That means all the values of pi, right? 1 pi, 0 pi, like integral values of pi, right?
All the integral values of pi.
So we can write n pi, where n belongs to z,
Right.
in range is
Minus
infinite to
infinite.
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 So we can say r. All right.
Right.
Now I can feel that it's bit easier for you, right? You are answering very
Yeah.
fast.
Yeah.
So cot inverse x. Let's draw the graph. Here in this
Yeah.
graph, we constrict or restrict the graph from 0 to pi. So the values will be
opposite
from,
of it. Yeah, x-axis will become y-axis.
absolutely. So now we have 0 comma infinite. That means infinite comma 0. That means when you move x infinite, the y will become 0. So this will be a point. And we have pi by 2 comma 0. So 0 comma pi by 2. 0 comma pi by 2. Let's draw this pi by 2 here. And we have pi comma infinite, minus infinite. So minus infinite
Right.
will be getting here. So the graph will look
So domain will be again minus infinity to infinity.
absolutely right. And range will be,
Range would be then minus pi to pi.
no. Look at the minimum value and the maximum value.
Okay. The minimum value is 0.
Right.
0 to pi.
And open brackets.
Yeah, open brackets.
All right.
Got it.
So please draw it out.
Done, sir.
All right. Now we have cosec inverse. First cosec x. 0 to pi, 2 pi, minus pi, and All right, this graph looks like this, very weird, but yes, because this is on Sine X, right?
Right. So it'll cross means there'll be 2 points, 2x points, or just one?
Sorry, 2x point means
No, no, okay, one only. Okay. And okay.
see, again, domain we can put all the values, but where they are becoming infinite, you can see
Infinite.
at 0, pi, 2 pi, minus pi.
One second. Uh, Domain will be the expression pi by 2. Okay, so it will like all the values between, but except the odd values, uh,
Odd
or
values
will it
of
be
integral
of
values
pi?
of pi, right?
Okay, integral
Absolutely.
values, not so. But
See, at 2 pi also this is becoming
okay, so
infinite.
right. The dotted lines you mean?
Absolutely right.
Okay.
And belongs to integer. And range here, range C, we are getting from this to infinite, or from this to minus infinite, but there is no value for y of this value, right? This is from 1 to
Why?
minus 1,
There is no value of y.
right? Because see, if you put 1 equals to y equals to half, you will never get half in cosec x, right?
Right.
So what we can say, range is r minus minus 1 to 1. We are removing minus 1 to 1 from the range,
Get the point.
right? Because see, sin x is from minus 1 to 1. So inverse of this 1 upon sin x will never be from minus 1 to 1, right?
Right. So if you
So we are
remove that
removing,
gap area, we can find the point easily of y.
absolutely. All right. So
Got it.
in cosec inverse x, what we do, we again restrict the graph from minus pi by 2 to pi by 2. All right. So minus pi by 2 to pi by 2. So let's draw the points. At let's draw this
Mhm.
point first. This is pi by 2 comma 1. This is a bit complicated, right? This doesn't look very nice. So at pi by 2 comma 1, so this is 1 comma pi by 2.
Just the
This will
opposite,
be
like the axis changes.
right. All right, and the minimum value will be minus pi by 2. Here at 1 we are getting pi by 2, and at 0 we are getting infinite. So at infinite we are getting 0, so 1 point will be here. So this part looks like this. Now same thing for the right hand side. This part minus pi by 2 comma minus 1. So minus 1 comma minus pi by 2. And 0 comma minus infinite. So at minus infinite this becomes 0. So you will get graph like this. All right. I told you this
Right.
is a little complicated to
Yeah,
understand,
it's a
but
bit cool.
what you can do, look at the NCRT, or better yet, go to Google after the class. Go to Google, look
Okay.
for cosec x graph and cosec x inverse graph. Then the drawings are very clear. In fact, you can move around. Like there are many
Mm,
websites where you can move around the graphs and you can get the feel out of it. All right.
right. Like
I
it'll be like a virtual type graph, something, graphic graph, something.
sorry.
It'll be like a 3D graph, something you mean.
Right. You can move around with it, right? So as
Got
you
it.
can see, I already have a bad handwriting. Then in drawing cosec graph is very
Yeah,
like
it's
ugly
troublesome,
for
but
me.
it's okay.
Yeah.
Yeah.
So domain here again, see, we can put any x, but minus 1 to minus 1, minus 1 to 1. So r minus
R
minus 1
minus
to 1.
minus 1 to 1.
And
Okay.
range here is everything from minus pi by 2 to pi by 2, but we are not reaching to 0. So minus pi by 2 to pi by 2 and we get it minus 0.
Okay. So and this curved brackets
Yeah,
represent
close brackets. Oh, sorry,
close.
this is
Yeah.
set, right? Sets. One element in
Okay.
sets is 0.
Oh, the third. Okay, set. Got it.
All right, we are removing from minus pi by 2, pi by 2. There is 0 also, but we are removing 0. All right,
Yes, sir. Got
so
it.
minus 0. Please note it down.
Yeah. Done, sir.
All right, so let's draw cosec. Oh, sorry, sec graph. Last graph is remaining.
Yeah, C graph, right? C graph or sec. Is it sec or sec?
I say sec,
Okay.
but the name is secant. Full form
Secant,
is
yeah.
secant.
Yeah.
All right, it is 0, 5. Domain here, again we can put all the values, but we cannot put odd multiples of pi by 2, right? At pi by 2 this become infinite, minus pi by 2 becomes infinite, so we can not put odd multiples of pi by 2. All right,
All right. Got it.
and
Okay.
range here again r minus minus 1 to 1, because same thing, cos x is from minus 1 to 1, so 1 upon cos x cannot be from minus 1 to 1. All right,
All right. So domain of sec x and tan x is same.
right. I'll draw the whole table, then you can see how to remember this or what are the patterns. All right.
Yep.
Sec inverse x. In here, we restrict the domain from 0 to pi.
Yes. 0 to pi.
So 0 pi, and this is pi by 2. So let's draw from this pi by 2 to pi first. All right, pi by 2 to pi. So at pi, we are getting minus 1. So at minus 1, we'll get pi. So this will be a point on the graph, minus 1 comma pi. At pi by 2, we are getting minus infinite. So at minus infinite, we'll get pi by 2. So this will be a point. So looks like this. Again, let's move on to this side. At 0, we are getting 1. So at 1, we'll be getting 0.
1 0.
And at pi by 2,
And
we are getting infinite. So at
at
we'll be
infinite will get pi.
pi by 2.
No.
Right? Pi by 2.
Yeah, at pi by 2 will get in 0.
So this is the graph. Again,
Right.
domain
So
here
will be all the real values
but
minus, yeah, minus it will be minus 1 and 1.
2 1. Absolutely
Yeah.
right. And
And
range,
range will be it will be all the values except uh it will be all the real values except
no, not all the real values. Look at
no
y-axis.
no no it won't
Maximum
be it
value
won't be.
is, sorry,
Yeah, it's pi and the minimum value. Wait. The minimum value is it's not touching pi by 2, right?
yes, it is not touching pi by 2.
So it'll be pi minus something.
No, look at the graph. The graph is this part and this part also. So what is the
Oh
lowest
yeah,
point in the graph?
yeah. It's one.
No, not one that you are looking at x-axis, at y.
Yeah, wait. The lowest point on this. It's 0. Okay, 0.
0, absolutely right.
Right,
So
right.
0 comma pi, close brackets, because we are getting 0 and pi, but we are not
Exactly.
touching pi by 2. All right.
Yeah, that pi by 2 is confusing. Then I was like, this. So it's not
I know,
continuous.
I know. This is not continuous, right? Because we have to
Yeah,
remove the pen from the paper.
yeah.
All right. So this is clear.
Clear, sir.
Yeah. Please note it down.
Yeah, 1 second. Done, sir.
All right. So let's just write the domain and range of all the functions. This is the functions, domain and range. So sine inverse x. Can you tell me the domain of sine inverse x? What we wrote?
Domain of sine inverse 6. Okay. Will be okay. So domain has all the real values.
No, sine inverse x.
Oh, okay. Sine inverse x. Okay. Sine inverse x. 1 second. Can I check the? Can I check 1 second?
Absolutely.
Yeah.
Please check.
Okay. Minus pi by 2 to pi by 2.
Domain.
Minus 1 to 1, right?
minus 1 to 1.
Minus 1 to 1.
And range is?
Okay. Minus pi by 2 to pi by 2.
Absolutely right. And cos inverse x?
Cos inverse x will be minus, it will be the opposite. Domain will be minus 1 to 1, and then range will be 0 to pi.
Absolutely right. Now tan
And
inverse x?
tan will be, domain is minus infinity to infinity.
That means r I can write.
Yeah. And r will be, range will be minus pi by 2 to pi by 2. Yeah.
And open
And
brackets, right?
yeah, open
Always say
brackets.
minus pi by 2 to pi by 2 open brackets. So like,
Even then, okay. For domain also, in minus infinity to infinity, open brackets, right?
right.
Okay.
So cot
Then
inverse x?
cot inverse x, it will be domain is all the real values,
All right.
and range is 0 to pi, open brackets.
Absolutely right. Now sec inverse x?
Yes. Then cosec, right?
Right. Sec. Cosec. Let's write cosec. All right.
Okay.
Cosec inverse x?
Cosec inverse x is r minus 1 to 1, open brackets.
Right.
Range will be minus pi by 2 to pi by 2, close brackets, minus 0.
Absolutely. Now sec inverse
Then
x?
domain is r minus 1 to 1, open brackets. Range
Right.
is 0 to pi, close brackets, minus pi by 2.
Absolutely. So this is the table we need to know, and you have to know this range and domain, right? So how to
Right.
remember? You can see sine cos minus 1 to 1, tan cot r, cos x r minus 1 to 1, right? Domain you can
Right.
remember very easily. Range,
Right.
if you look at sine, tan and cosec are similar,
Sine, tan, and cosec.
and
Okay.
cosec, right? Minus pi by 2 2, minus pi by 2 pi 2, minus pi by 2 pi by 2, minus 0, right?
Yeah. Yeah.
And same thing for cos, cot and sec, 0 to pi, 0 to pi, and 0 to pi, right?
Right. And only for cosec and sec, we have to add, subtract something at the end.
Right.
Got it.
So this is easy to remember if you look at it very closely and write it down few times, then you can easily remember this. All right.
Right.
So note down this table,
Yeah.
and this is very important. Even if you forget the graphs somehow, if you remember this domain and range, then you can draw the graphs very easily. You can solve questions very easily. All right.
Right. So I'll have to by heart this table somehow.
Absolutely. If I ask you what is the domain and range of tan inverse x, you should be able to speak it like it is your name. All right.
Okay. Got it.
Yeah.
Then so.
All right. So now there are few properties we need to know. Everything clear till now?
Yes, sir.
All right. So
Yeah.
first property about this cell. Just give me one moment, all right?
Yeah, no problem.
Sahal, the class is for 1.5 hours for today. All right, I have been informed this,
Yeah, so 1.5 hours.
right?
I guess
So
it's
from
yeah,
next week we are keeping for 2 hours, and also we did a lot today, right? All the graphs and domain and range.
right, right, sir.
So for revision also, it will be easier for you. All right.
Right.
So I
Mm.
hope you understood everything.
Yeah, till now I understood everything. The graphs I'll revise one or twice, and if
Right.
I have any
Your voice is breaking, Sahil.
issues,
You are
I'll
not.
WhatsApp you on next class.
Uh,
Are you able to hear me now?
yes, now I can hear you.
Yeah. So I said that I'll practice the graph once or twice I reach India, and then